Okay. So how would we create a confidence interval? So here's what we're going to do. If we've got a normally distributed variable and the population standard deviation is sigma, and so we're trying to figure out where the population mean is, our confidence interval for the population mean, we're going to take the critical value of z, so we just found it's 1.96 if we're at a 95% confidence level. It's going to be different if we're at a different confidence level. There's our standard error, and so that's our critical value. So if the variable's not normally distributed, it still is true as long as our sample is sufficiently large, and a very frequently used rule of thumb for that is that the sample size needs to be at least 30. Okay, so let us suppose that the population standard deviation for a certain plant species height is 4.3 centimeters. We have a sample of 42 plants of this species, and we end up at a mean height of 39.6 centimeters. We want to figure out the 95% confidence level. Okay, so let's write some things down. So our n is our sample size, that's 42. Our x bar, that's my sample mean, so the mean height in our sample, that's 39.6 centimeters. So because my n is over 30, remember what we set up here is that the confidence level will basically be normal. We can follow a distribution when we are constructing the confidence interval. We're going to get more on that later. Oops, sorry for the crazy scrolling here. It's a little out of control. All right, that's better. Okay, so the first thing we want to do is find our standard error. Okay, so this is going to be the sigma of all the x bars. So that's going to be sigma divided by the square root of n, population standard deviation divided by the square root of the sample size. So this will be 4.3 centimeters divided by the square root of 42, which is approximately equal to 0.664 centimeters. Okay. So then what we want to do is we want to find the critical value of z. Okay, my 95% confidence level. This means that my alpha is 0.05. Okay, so for those of you who are not used to this symbol I just wrote is what we call an implication symbol. It's a nice little shorthand. So implies or leads to. Okay. Okay, so we've got our confidence level. Let's draw a quick little sketch. Okay, and so basically here's what my sketch is doing. I'm just making a note of how much area is in each end. What's going to be in each end? Alpha over 2. So what's half of 0.05? 0.025. If you're saying we just did this, well, you're right. Okay, and so then we use the same procedure that we did a moment ago. We figure out that this is 1.96, and therefore on this side, remember I'm going to put a negative sign from this because it's the negative of the other one. This is going to be negative 1.96. So we got that from our table. I'm not going to show you again because we just did it. Okay, so now we want the upper and lower bounds for our confidence interval. Okay, so we're going to do my x bar, my sample mean, plus my critical value times my standard error. You're going to hear me say that over and over again all throughout this chapter and the chapter on hypothesis testing. We're going to take our point estimate, add the multiplier times the standard error. That works for all kinds of statistical tests. It's the same general principle for all of them. Okay, and so this is going to be what? This is going to be, I forgot what my x bar is. It is 39.6 centimeters. 39.6 centimeters plus 1.96 times that standard error. Where did I get my standard error? Right up here. Our sigma over the square root of n. See that 0.664 centimeters? So grab your calculator and work this out. And you should get approximately 40.90. I'm going to round it to the second decimal place. We usually round it to one decimal place beyond where our mean was rounded to. Okay? And so then we're going to do the lower bound. Which is going to be x bar minus z.025 sigma x bar. Okay, so take your sample mean. This time we're going to subtract our same multiplier times our same standard error. If you have a graphing calculator or some other calculator that remembers your previous calculation, you can go back to it. If you've got a TI graphing calculator, you can do second entry, and then you can retype over your previous calculation and just change that plus to a minus. It's a real handy little trick on this. Some scientific calculators will do that too. Look for your second function entry. Not all of them have it, but many do. So this is going to give me 38.30. Okay, so that means that my 95% confidence interval so a lot of times this gets abbreviated. So we're going to write it in interval notation. So this is going to be 38.30 and then 40.90. Okay, so that is our 95% confidence interval. Let's go ahead and find the 90% confidence interval, just so that we can compare them. Okay, so let's draw a little picture of our normal curve for this one. Okay, So what is our alpha? My alpha is you're going to take your 90%, switch it to a decimal. And sorry, I did that the wrong way around. I need to subtract from 1. 1 minus 0.90, which is 0.10. So if your confidence level is 90%, then your alpha is 0.1. Okay, so now I go to each end. I'm going to mark off a little shaded area on each end. Okay, so this end, I'm going to put alpha over 2. So I take that 0.10, I divide it by 2, which of course will give me 0.05. On this side too, same thing. My alpha over 2 is going to be 0.05. And so now, my critical values, though, are going to be different. So we've got a z. This one's going to be negative. This one is going to be positive. And my subscript represents the area that's to the right of this positive one. So this is going to be z subscript 0.05. And this one is going to be the negative of that. Okay, and so the area in between these is going to be how much? The area in between these is going to be 0.9. Whole thing's got to be 1. So if we've got 5% in each end, then that leaves us 10% in the ends, and so 90% to be in the whole middle. Okay, so now we need the area to the left. So this area to the left is going to be what? It's going to be 0.95, right? Because we subtract the 0.05 that's off to the right, and so that leaves us 0.95 to the left. And remember, this goes infinitely far off to the left. We've got an asymptote there. Okay, so then what we're going to do is we're going to look up the area equals 0.95 in the z-table. And then we're going to use that to get the value for z.05. So this is my critical value. Okay, so I go back to my table. I try to find area of 0.95. So those are the negatives. You can see all those are smaller than 0.5. That's the left half. I want the positive, so I want to find 0.95. Okay, let's looky here. So looks like right about there. So what we have is halfway in between those two, 0.9495 and 0.9505. Okay, so let's come back. So basically the area equals 0.9495 gave me a z-score of what? 1.64, and the area equals 0.9505 gave me a z-score of 1.65. Let's go look at that again and make sure that we've got it. Let me scroll down. There we go. Let's find these again. Okay, hang on. Those are the wrong two. These are the two I wanted. Okay, so if you look, where are we? I'm just highlighting them here. So this first one is 1.64, and then the next one is 1.65. Remember, you add the number down the left to the one at the top. And so we're halfway in between 1.64 and 1.65. Okay, so usually what I'll do if I'm doing a table is if my area is much closer to one or the other of those, I will pick the closest z-score. If it's halfway in between or close to halfway in between, then I will average them. So in this case, this is right at halfway in between, at least when everything's been rounded to 4 decimal places, like in that table. So I am going to average them. And you can probably do this in your head, but if not, you can take your calculator and you can add them together and you can divide by 2, and this is going to give me what? 1.645. Okay, so 1.645, you can see how that could be done in your head, right? Okay. And so that's going to be what I'm going to use for my z-score. Okay, so now to get my confidence interval, once again, I do the upper bound and the lower bound. Here's another more concise way to write it. My x bar plus or minus my critical value times my standard error is going to give me 39.6 centimeters plus or minus 1.645 times my standard error, which was 0.664. Same as before, the confidence level does not affect the standard error. That's going to be the same for no matter what confidence interval you use. So that's what we did previously. Okay, and so that's a concise way to write it. And so if you want to do the upper bound and the lower bound, you could write that out. And so this gives us our interval. That my 90% confidence interval, once again, abbreviated CI, and that's a very common abbreviation. You'll see that in academic journals and so on when they put things in tables. They'll use the CI as a standard abbreviation for confidence interval. So this is going to be the interval 38.51 and 40.69. And the way I got those was I just used my calculator on this calculation. First I did the plus and then I did the minus. Actually, it doesn't matter what order you do them, but be sure the small one comes first in your confidence interval. So then here we go. Okay, so let's actually compare that with what we had before. And let's put everything on a number line. So here's a number line. Here is my x bar, which is 39.6 centimeters. Okay, so let's just say this is 38.51, and this is not going to be an exact to scale measurement of this, so that I know these two should be the same distance apart. Okay, so let's now go look at my 95% confidence interval that I already got. Let's scroll back. So where is that? 38.3 and 40.9. So let's see where those fit on here. So 38.3 is going to be further out, right? So this is 38.3. And then my 40.9 is going to be also further out, right? So basically, this, let me mark it above, this right here is my 90% confidence interval. And so then where is my 95% confidence interval? it is further out, right? So where would you expect the 99% confidence interval to be? Further out still, and it will work that way every time. So basically, if you want to increase the confidence, if you want to be more sure, there's going to be a sacrifice in terms of precision. So our estimate, our range is going to be wider. We can't bracket it as closely if we want to be more sure of having the population parameter be contained in there. Okay, so that's the relationship between the different sizes of confidence intervals. Okay, I hope this helped you understand how to set up confidence intervals. See you next time.